So I'll just, this is Peter Kuria, and I'm demonstrating for event-driven microservices. And so event-driven microservices. And so this project is based on uh, event architecture. So I'll just remove my video because I think it's hanging up, and I hope the audio is not very well. So forgive me, let me remove the video so that I can have a good startup. For the project, we are learning a microservices-based application. You can see already these are Spring Boot microservices. They are all learning, and then from here, just briefly explain the services and microservices. Microservices monitoring. We have the API. We have a number of like 6 or 8 microservices. The API gateway acts as the entry point of all our services. So this is like it can be used to implement load balancing, weight limiting, late limiting, and also can also be used as a uh, load balancer, as I said before, authentication service, and then so also we have discovery service. Discovery service acts as a registry, like our DNS registries for mapping the various microservices. Inventory service is for obviously if the item is not in service, when an order is placed, the application has to check first the inventory database whether that order exists, the item exists in the product service or not. And then of course the product service is where we are storing we are persisting the product. In this case, we could go with the healthcare. If we say our case model is the healthcare, so you see, like I have a number of like 3 databases for persisting data for microservices. Now, this MongoDB NoSQL database is being used by is being used by the product service. And then maybe I'll just show you briefly. So this is just a backend application, and being a backend, we have the services they are up and running. Maybe to demonstrate how it is working, then I'll go through the code briefly through the code. And so let me just show. Let's say if we're asked, getting an order. So we can go use Postman or NF100 fronted. So for this one, I'm just okay to start with. There is an element of security provider. For security provider, we are using Keycloak as a security provider. The one I've just logged in. And so from this Keycloak security provider, it gives us the auth2 authentication, authorization for that matter. So all our endpoints, they are secured with credentials and tokens. So we already have, let's see, a token provider, and then as a minute, let me, so can confirm whether the token is correct. So we're starting with SU. Let's see Postman, whether the header. So when we are sending the this HTTP post or whichever query we are sending, could be gRPC, could be any kind. So in this case, we are sending HTTP a post to the API/order, and then it's taking so the token is correct one. So we are using the token. If you check from here, this is a token we are using. So this is a token. Sigma looks invalid. Let's see. Looks invalid, but let's see whether it could send an order. Previously successful, as you can see from here. So I'll try to resend and see whether it will be working. Let's see. Oh, good. Well and good. So the order has been sent and has been successful. So the way it works now is for the this application, the so if you go to the order service and the log, see here we just choose an order, and this is the order ID. Just now we and then this order is via software. This way we so we are now so there is an notification script which we which so the order is produced with what we then this and the order once an event is sent to the order service is able to send an order the order services send the applications. So we are on application and using this another is sent from the order service to the inventory service, and then the inventory service is just confirm whether what then is whether to send the that then is asking whether to send the order. Then so in this case, so where we are exposing, we have this class inventory service. Then this is just checking whether let's say we have an object which is just initiate the when the application starts. But in this case, I've seen that the service is able to whether an order is locked. So it checks whether anything is incorrect. So just combine all those codes because we could as well have sent many queries at the same time, and then it can confirm whether recording is stop. That's confirming. Now I think I had missed that one. So back to my main thing. I was saying the order, the request has been successful, and then we will be checking. So the order has been placed successfully. You could even send another order, like 2 items, depending on the body. We could send like 2 items at the same time. Let's see whether this one will be successful. Let's confirm. Just send. Yes. So an order has been placed. That's another order. I need to be persistent in the database. Let's say maybe you can go to our database. So our order service database where the order service microservices persisting the data. So before as we wait for MySQL to load up, I've already demonstrated we have now a Keycloak as our auth 2.0 provider. And then I have this we have this Eureka service. The Eureka service acts as our our discovery server. So for discovering the microservices in there, we have this application. So you can see the services which are up and running. So the API gateway is running on port 8040. Then the order service on. So this is the one which we are querying. We are sending request to this port 8090. As you already seen, they are all running on the my local computer. So they are all running here. And you can see even the logs. For example, we have just received another order with this order ID. If you go to our database, supposed to see an order ID. What was the order ID? Let me just confirm quickly. So the order starts with AHD. And clear it is the same. It's the one. So we have been able to demonstrate that. And then maybe, so the Apache Kafka, the broker itself is running on, this is the Apache Kafka, and then it's running on, it's Dockerized also. I've Dockerized the application. So let's see. So the application is Dockerized, and some of the application they are running on the localhost. And so, and just a second. I wanted to show you the logs of Kafka so that you see the nodes. Let me just show the logs. I think from here, sometimes you hit issues when you're running on Windows. Actually, that key clock is containerized as a Docker container. So it's running on this port. So this is the image. And so it's running as a container on my local computer. And so for the event-driven architecture, the Apache Kafka, it's dependent on Zookeeper. Zookeeper acts as the control plane. This is the control plane of the Apache Kafka, for that matter. You could decouple Zookeeper from the broker because they call that's an implementation of the Apache Kafka, how it works. So these are some of the. So for these microservices, I could either run them on my computer, on a container, as you see, on a localhost, or I could also open them, learn them from a localhost computer. So in this case, I prefer to run just a few microservices, the Zookeeper, the Zipkin, and also those external dependencies on Docker to Dockerize them. And then for the other microservices to run them on my local machine. So, hope it's still recording. And let me check. I have to keep checking whether it's still recording. Yeah, it's still recording. And so I was about to demonstrate how event-driven architecture has been implemented. And I have just demonstrated, for example, a node has been sent. We have sent a HTTP post, and then the HTTP with authorization. We are using JOT tokens, and for all those are from our key clock as our provider. So you see, we have been provided as a secret. The secret has come from the secret is coming from our key clock portal, as you can see. So we already logged in as admin. So this is helpful for ensuring that all the microservices, inter-microservice communication is authenticated. So, so you can see the clients we have, we are in this realm. We are in this realm. And so there's a there's a lot to talk about. Uh, there's a lot to talk about key clock, but for this video, I'll keep it short. And then, so we have seen that an order has been placed and it has already been persisted in the database. It has been persisted in the database. So all the orders which are placed are stored in the database, as I've already shown. So these are the previous orders which had been requested. You can see, and then so we have let's say order service is persisting its data onto this database. And then the way it is working, maybe I will just open a terminal and just showcase the. Let me just open a terminal and let's see. Let me open the container. Let me just open the container. I think it's already open. Just open a terminal. So the way I've deployed this application is I just build them locally, then push to my Git Docker registry. So Docker logs. I'm trying to. I'm intending to. I want to see the Docker logs for our Apache Kafka broker. So there's a notification service, as I'll demonstrate. Maybe I need to demonstrate this. That there is in our implementation. You see, so there is this inventory service. Is how we're exposing the data through a DTO. Then there is a repository. There's all this implementation, we are just combining all the SQ code instead of mapping, instead of calling uh, instead of querying our API here slash inventory service, just normal. we're just combining all the SQ codes to one, all the code, because in a normal production, you would really call it from product. You just want to combine all instead of querying one by one. You're using a number of libraries like SL for J, Lombok for, since you can see now we don't have a constructor here, it's hidden from implementation by using this library. And then of course constructor is not there. And then for logging, rate limiting, and all that. So let me just I wanted to explain the code for the DTO. Of course, this is the response, and this is the properties which we whether item is in stock or not. Item is in stock or not. I hope still recording. Okay, so I think it's good. So from here, item is in stock, inventory service. Yeah, so that is how we are mapping the inventory response and then exposing it through a service actually. So this is a service. We have this method is in stock, and then it's checking, it's logging. Then this one is sending to so this is already the inventory service stream. We are mapping out to all the items which are in the inventory, and then giving it a list, giving it, if the item is on list, you can see find SQ code in inventory. So the item we are querying the if the item is true, it's going to return the object. So a lot of explanation here. And then this is a controller. As you can see, instead of querying just like one item here, like this, instead of querying one item, or combining like the way we expose like HTTP plus 8081. In this case, it's 8081 instead of having one. If you visit the application, so we are just combining all of them into one. So then this we are creating a list of all this. We return a list of inventory the list. So maybe that's why yeah, there is a list of the items in stock, as we have seen in Postman. So maybe for that we could see the items which are already in stock through API products. So we want to get, let's try to get some item you see. So we can get the items which are already in the database, as you see. So the API slash product is working. So we have this number of products in our in the MongoDB where our products service assistance data. And so these two queries using this Yes, my mic was dropping, and here you are back. Yeah, here once again. So once these logs cool down, stop cooking, so the logs, we're able to see all the what's happening in Kafka. So let it settle down, and then I can show that another has been placed. In essence, if you check from this side also, from the services side, you could be able to see the logs that a notification, receive the notification for the order. And then you could be able to see we are group ID, Apache Kafka. This is the Apache Kafka consumer ID notification group 1. And here, this was showing the previously. We are in a group, this group, and we are on a consumer group. So Apache Kafka, the way it works is by implementing partitions. So we are we are writing a log file. So, not only Apache Kafka not only works as a event messaging, or would you say writing to the logs, but also other streaming. So this log, you could pick it, any application which you have can pick this one and act on it. So this was sent by the other service. So the application service is up and running. You see, we are listening. It's just getting the resolution through the discovery service. In this case, Eureka. API gateway acts as our authentication, as our entry point for resolving the endpoint. So that's why you see it's getting the counts, the late limiting and all that. The other service, we demonstrated that another has been placed. Then I think that's all. So I think I'll end this video. I'll make another better video demonstrating this logs. Let me just show why. Oh, now I think it stopped. So yeah, so there's a lot of logs going on here. So there you can see there is Apache Kafka, we are on broker 1, and then processing automatic preferred for log. There are a lot of logs here for Apache Kafka, and there is a leader election, as you can see, a leader election. The way Kafka works, I have documented in the documentation, but the nodes are working well. Just here we are confirming that the nodes, the controller, which is a zookeeper in this case, the control parameter zookeeper, is working well, and the node is working well. And then you could have some notification messages like in this end showing that assignment has been received, consumer notification from this, for group notification ID for generation at 7. So this was just showing that a message has been sent, and then it has received and relayed it to other services. So the way these microservices are communicating is through this. Unlike in this, when I'm sending this post, this is just synchronous, direct, uh, synchronous. The API is expecting a response. But in this case, as I've demonstrated, in this case, uh, I've demonstrated here. Now we are able to get item, to request item in the database, and so on. So that's it. And okay, this is the schema. This is the schema of the application. This is the UML diagram of the Postgres. And then for for the database, for the products, these are the products persistent on the MongoDB. And then for I have for the orders, I have already demonstrated the orders. Could have on the front end just a form to take on these inputs. Let's say post, get, an order, then to be mapping them with. That's another. If I was to do it, I would have added a front, just a front end, but then just demonstrate. It's able to demonstrate that working by. Let's see. The item is. You could see the response. The order has been placed successfully. So that sums up. That sums the whole demonstration, and I guess Uh, can end that one after now. Thank you.